Now, how do we find the area of an oblique triangle using the sine function? So I want you to recall that the formula of the area of a triangle in general is 1/2 times base times height. So in order to use this formula, we first have to put the height, put the perpendicular to the base, and figure out that the height of that triangle, and then use it into the formula. But right now we're gonna see if we can avoid doing that and basically create a shortcut for finding the area. Well, we're gonna use the knowledge of our trigonometry function. So, I mean, yeah, the knowledge of trigonometry in order to come up with a formula. So let's say we need to express h, right? Let's say we know this angle alpha, we know all of the sides of the triangle. So we're gonna say sine alpha, sine of this angle is opposite over hypotenuse. So sine alpha is h over c. So now if we solve this for h, we're going to have h equals c times sine alpha. So now if we plug in that value for h into the formula, what do we have? We have a equals 1/2 b times c times sine alpha. And we can use that same process to figure out that a is also 1/2 a times c times sine theta, or it's 1/2 what else, ab times sine gamma. So we could use these formulas to find area of the triangle if we know one of the angles and the other two sides. Okay, but you may ask, okay, this works for when alpha is an acute angle less than 90 degrees. What about if our angle is obtuse more than 90? Then what do we do? So our height is outside of the triangle. It's not inside the triangle anymore. And the angle that we're going to be using here, it's going to be a supplementary angle to angle alpha. So it forms 180 degrees with alpha. So that angle is 180 minus alpha. Okay, so again, we're going to use our sine function, sine of the supplementary angle to alpha is opposite over hypotenuse, so h over c again. So we have sine of 180 minus alpha is h divided by c. So multiplying both sides by c, we get c times sine of 180 minus alpha equals h. Okay, now let's apply our formulas that we've learned already to sine of 180 minus alpha multiplied by c. So I'm going to keep the c outside here, and I'm going to apply my formula. So I'm going to get sine 180 cosine alpha minus cosine 180 times sine alpha. Okay, equals h. Now, what do we know about sine of 180 degrees. That's a 0. And 0 multiplied by anything is a 0, right? So we have 0 and then minus, what's the cosine of 180? Cosine of 180 is -1. So we're going to have this negative is from the formula, and then we have a -1 multiplied by sine alpha equals h. So in the end, we still see minus times minus, negative times negative is positive. So we still see c times sine alpha equals h, just like right here. So we're still coming to the same conclusion, same formulas. Okay, let's go ahead and use our knowledge, our formulas. In this example, it says find the area of a triangle with sides 90, 52, and angle gamma 102 around the area to the nearest integer. So we have this triangle with an obtuse angle. So let's try and depict it. So this is 90, so 102 would be like probably something like this. And so this is 102, and then we have one side, A, is 52, and the another one is 90. So this one is about half of the other one. Let's do, this one is 90, and that's going to be side A, and side B is 52. So there we go. That's our triangle. We need to find the area of this triangle. So we know that the area is 1/2. Well, which sides do we know? We know A and B, right? A times B, and that gives us sine gamma. All right, according to the formula. So let's just plug it in. 1/2 90 times 52 times sine of 102. And when we put this whole thing into a calculator, we get approximately 2,288.87 units, square units. All right, so that's how you solve this problem. Now I want you to try to solve another problem by yourself, which says find the area of a triangle given by, you have angle beta 42 degrees, side A, which is 7.2 feet, and side C, which is 3.4 feet. So your answer should be in area in square feet. And in the direction it says round the area to the nearest tenth.